Good morning everyone. So now I am going to show you how to generate 50 Hz square pulse in Vhdl coding in ISE design suite environment, that is Xilinx integrated software environment. So this one I am going to feed to one FPGA controller, so that I am using this. This is the environment. So parallelly I will show you the procedure how to work with ISE. Okay, ISE in the sense Xilinx ISE. File, new project. So here I am giving some name of the project, example 1. I am giving next, and then I have to choose the family. For example, I am doing coding, then I need to dump into one digital FPGA controller so that I can get the 50 Hz square pulse in the output. So for that I am selecting. Right now I am having the board of Spartan 6 LX9 TQ144, and then I am giving next, finish. So now just I created one empty project. So now I am going to create new file, new source. Right click on experiment 1, new source. Here you can find lot of new sources like schematic, user document, Verilog model, Vhdl model. So we need to select Vhdl model because I am going to write the Vhdl code only. So I made a SQR. Actually Vhdl is case insensitive, so you can give small letter, capital letter, whatever it is. So I'm going to generate one square pulse with 50 Hz waveform. So in Vhdl, in later videos we'll see about the Vhdl basics, but in Vhdl code there are two important things. One is entity and another one is architecture. So in the entity we need to declare the input and output. So this is the entity, and then this is the architecture. So in entity I am writing port. See, one thing, each and every language has two things. One is its syntax and another one is meaning. Syntax in the sense set of rules and regulations. This word can be used by like that only, like that some rules. And then meaning, whatever we are writing it should have some meaning. So okay, so I am this is the syntax. I am declaring one clock in std_logic. So we'll see up to simulation only. So later videos we'll see about implementation. Okay, clock, and then I am taking one square out. Okay, so as per the syntax of that Vhdl code, the last variable should not having the semicolon. Here we need to put semicolon. This is all the syntax. Okay, so clock in the sense nothing but in our FPGA board we have designed one crystal oscillator. That oscillator can generate some frequency. For example, the board what we have has the 20 MHz. So based on the 20 MHz only we need to generate the 50 Hz because we need some reference clock frequency. Clock in the sense high low, like 50 nanosecond it will come. 20 MHz means 50 nanoseconds. That is 1 by f, right? So from that only I am going to find the 50 Hz. So for that I am taking the calculator. My clock frequency is 20 MHz. So my required frequency is 50 Hz. So 20 MHz divided by 50 Hz, I am getting 400,000. That means if I have the 400,000 of clock, then it will form one square pulse, right? So in the square pulse we have two samples, one is high and another one is low. So I am making divided by 2. So 200,000 time on and 200,000 time off we need. So here I am writing the code begin process of clock, and then begin if rising edge of clock, then I made end if n process. That means each and every rising edge of clock I am going to count one counter, SA ascend equal to SA plus 1. So every rising edge means every clock I am counting, and if SA is greater than or equal to 200,000, then I am making one temporary variable temp% equal to not of temp. and then I am making again SC ascend equal to 0, and end if. So this temp I am moving into square out. Okay, so that means what I am doing, I am counting each and every 200,000 clock. Every 200,000 clock I am changing the state of temp. State means it is previously in 0 condition and then it goes to 1. After 200,000 again it comes to 0. After 200,000 clock again it goes to 1. Like that keep on it is changing the states. So I need to declare all the temporary variables here. Signal SA is integer initially equal to 0. This is the procedure. Signal and then the variable name and then its variable type to integer and initialize value. Like the way I am declaring signal temp std underscore logic initial equal to. So if it is a logic in the sense zeros and ones, right? If it is a digital zeros and ones, then it should be declared in single quote. If it is an integer, no need of single quote. So this is the difference between the giving the values, forcing the values to the std logic data and integer data. Std logic in the sense it will come zeros, one, undefined, unidentified, like that some data types will be. The integer means it's 2 power minus 31 to 2 power plus 31. Okay, so this is the code. So after writing the code, so first you understand clearly I am counting the every rising edge of clock. After it is reaching the 200,000 clock, I made 0 to 1. Again it is comes out of from the loop. Again it is keep on counting. Again if it is reaching to the 200,000, again it changes states. So we can find the square wave. Okay, so after that I am saving this, and then here in check syntax I am making the check syntax, because after writing the code we need to make check syntax as per the C language. So first initially we have the library declaration. So after that input output declaration, and then we will do the function body. Like the way here also, these are the library declarations and then input output declarations, and then this is the function body. Okay, after syntax, that means my program is okay. Then I need to verify logically it is fine or not. So I am selecting the simulation tool, and then I am giving the simulate behavioral model. So it is asking about the process. No. So in the model sim, this is the simulation tool. We need to check the simulations. One more advantage of FPGA controller compared to another controller. So while developing the coding itself, we can find the simulation. So we can verify our logic almost 100%. If it is not having any feedback, real-time feedback, we can verify. So I am giving clock, right click, and then I am giving the clock of 50 nanosecond because 20 MHz. And then I will run, and if I zoom means I can find the square pulse. So if I want to find the frequency of this square pulse, then I have to put one cursor here, and then another cursor here. See, 50 Hz. So this is the way of generating the 50 Hz square pulse from the Vhdl code. So implementation point of view, upcoming videos will see. Okay, so please, initially I made some video, so you have given some good response, so I am doing some videos. So please subscribe and keep supporting me. Okay, thank you.